Okay, greetings one and all, and welcome to day number 2. Yes, day number 2, week 6 of our journey together. And it's definitely a delight to have each and every one of you here for this evening's class. Let's head up. Today is Tuesday the 13th of February, 2023 or 2024. The subject is, of course, mathematics. And the topic is, I guess we're going to continue with the series that we've been doing. So the topic is pie charts. All right, so we're going to continue with that from yesterday. Pie charts.
Excuse me, Mr. Pati.
Go ahead.
You won't believe what subject we on, man.
What subject are y'all on?
We on the elemental set.
Oh, y'all on sets.
Yes.
Do you remember how to do sets from last year?
Yes, sir.
Okay, good. So hopefully you do well on that topic. All right. So yesterday we looked at it was a question dealing with colors, right? And we looked at, how to find it, and based on the degrees that we have. And so that's what we was doing yesterday. And so today we're gonna continue in that same vein. We're gonna be drawing we're gonna be drawing a pie chart. Sometimes they call it a circle graph. So that's another way to refer to it, a circle graph. So pie chart or circle graph. So let's first draw it. So use a compass to draw this. Use your ruler. It's not yeah. You're gonna need your ruler, but first of all, in order to draw the circle, you're gonna need a compass. If you do not have a compass, then you're gonna use a circular edge to draw this. All right. But make sure it's nice and neat. And I want to start off with yellow again. That yellow was nice. Okay, so we're gonna draw our pie chart.
Excuse me, Mr. Button.
Go ahead.
After the subtopic, will we be dealing with angles?
Angles.
Yes, sir.
No, we already did angles. We did angles last year before you came to this class. Now certainly we have to review angles, like go over it again, but we did angles before. We did all of angles, like we did all of the angles, acute, obtuse, all of them. All right,
Okay,
but we have to review them. We have to review them before the exam. You understand me?
Yes, sir.
Okay, good. All right, so let's begin. Hero, are you here? Where's Akiro? Akiro, can you hear me?
Yes, sir.
I need you to send me the notes from yesterday.
Yes, sir.
All right, so let's begin. So we have hopefully everybody have their circle drawn already. What we're gonna do here is we're gonna have this line, use a line. And so you have the line here, and let's say we have something like this on this side. All right. And let's say that on the other side we have, let me put this up a little bit up some more. And let's say that on the other side we have, so use a ruler to draw these lines, these straight lines. And let's say that on this side we have this. Okay, good. All right, so let's say that this one is, let's say that this for this end, we have, let's call it cloudy.
Excuse me, Mr. Patel.
Go ahead.
I can't hear you properly.
You can't hear me? Okay.
Hey, Mr. Petit.
How about now?
Yes, I can hear you clear
So
now.
let's say after this one, we have cloudy on the side. So we call this cloudy. Let's say
Please,
that
somebody had a question.
On this end, we have, let's say we have sunny. So all this sunny. So we have cloudy, then we have sunny. And then on this end, we have rainy. So cloudy, sunny, and then finally rainy. Cloudy, sunny, and then rainy. Okay, so let's just say that what we have here is, for the rainy, let's just say that it is 72 degrees for rainy. Let's say that for sunny, we have, let me put this up some more so we got it properly. Let's say that for sunny, we have, please make sure I draw this diagram. So for sunny, we have 168 degrees. And for cloudy, well, we don't know what the amount of degrees and stuff is for that. We just have it just like that. All right, so let's go ahead and start. So it says here, the pie chart. The pie chart shows the weather for the month of September. So we have a pie chart showing the weather for the month of September. We have some parts it was sunny, some parts it was rainy, and some parts it was cloudy. Okay. So the first question says, calculate the size of the angle. Calculate the size of the angle representing cloudy days. Calculate the size of the angle representing cloudy days. This one should be pretty easy. Anyone have any idea of how to do that? You want to figure out the size of the angle representing cloudy days. Anyone have any answer?
You can subtract
How are we gonna get
100.
the size of the angle representing cloudy days?
You
Nevaeh, if you're
take
talking, I
away.
cannot hear you.
You
Yeah,
can
yeah.
subtract 168 from
Can you let me?
72.
Okay, can you let me now?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
I don't know, I couldn't hear you. All right. Please. Nope, I can't hear you. Let me?
Yes.
Yes,
Yes,
sir.
sir.
Okay. I couldn't hear you all at all. Okay, so now my question again, calculate the size of the angle representing cloudy days.
I think you subtract 180 degree 72.
Say it again.
Subtract sunny 168 degrees 72.
No, we want cloudy.
I think you add all of them up together and you
168
subtract it by
plus
360.
72 and subtract it from 360.
Why from 360?
Because angles at a point add up to 360.
Very good. Because angles in a circle, they add up to 360. So the first thing we're gonna do, just like we did yesterday, we're going to what? We're going to add, right?
Yes, sir.
And so
Yeah.
I'm gonna add 168 plus what?
72.
68
72.
plus 72. And so when we add 168 plus 72, what do we get?
240.
240. Anyone else got 240?
Yes, sir.
Yes, sir.
So
Yes, sir.
240. So we add them. Let's call that. Let me put that in green. And then we have we're gonna subtract. So that's gonna be what? 240 minus
Take
what?
away 360.
No, I'm sorry. 360.
360 minus 240.
Yeah, minus 240. And so 360 minus 240 is going to give you what?
120.
120.
120. And so what that means that the angle representing cloudy is how much degrees?
120 degrees.
120 degrees.
Very good, 120 degrees. So
Excuse me, Mr. Petit. Sorry
ahead.
for interrupting.
Mhm.
For me, is there any specific work that I have to be doing, or could I do this?
you finished IXL?
Yes, sir, but there was like two sets of work that I didn't really understand, but I still did some of it.
We did some of it. And you did all of the videos so far.
Yes, sir.
Okay, good. Okay, yeah, then just focus on this.
Okay. I mean, yes, sir.
Okay, so all right, so we're gonna put in, where's Sky?
Yes, sir.
Sky, you have outstanding work for me, right?
Outstanding.
Yeah, did you send the solving linear equations? Did you send that one?
I think I did. I'll look back at my book real quick.
Solving linear equations, and then
I
also
did.
you did that? Let me
Yes,
check.
sir.
Sky Cash. Did you send it to
I-
me? The last thing,
Yes, sir.
the last thing I have from you is circle theorem. Wait, no, that's not true. The last thing I have from you is
Simplifying algebraic
some of
expression.
the algebra expressions. Yeah. Okay, so you have solving linear equations to do. Yeah, you didn't do that. Do you have the video for that?
I think I do.
Let me send it to you. All right, good. You should have it. All right, so we're gonna put what, 120 degrees for this
Excuse
one.
me, Mr. Petit.
Go ahead.
You said you subtract by 360 because angles in a circle add up to 360.
Yeah, or you can say angles at a point add up to 360 degrees.
I understand.
Well, technically speaking, they say angles around the point. So that's another way they phrase it. So good. So do we understand how we got 120? Let me know if y'all understand.
Yes,
No.
sir.
Yes, sir. Yes,
Yeah.
sir.
No, sir.
Jevin, I'm not even gonna pay attention to you. I honestly am not. Because all it is, we did the same thing yesterday. 360 minus the sum of.
Never mind.
I know. You always go ahead.
I did it.
You did it? Did you send it to me?
I saw.
Okay. All right, good. And did you do the IXL from yesterday?
I wasn't here yesterday. I was feeling really bad.
Okay, let what's her name? Someone to send you the link.
Yes, sir.
Okay, so the next question is, so we already know how many degrees is representing cloudy days. This is an interesting question. We haven't done anything like it before. It says, for what percentage of the days is it rainy? It's a good question. Very good question. B, for what percentage of the days was it raining? What percentage of the days was it raining? Very good question. Anyone can answer this.
I think you must add all 140 plus 120.
Nope, definitely not. Anyone?
You might have to subtract 72 from 360.
No. They say for what percentage?
I
Like
think
72% over
72
100.
over 100.
Say it again.
72 over 100.
72% over 100.
Say it again.
72% over 100.
No, definitely not.
Is it 72%?
No, definitely not.
72 over.
Let me see. I think Kingston should be able to answer this. Where's Kingston? Oh, Aaliyah was saying something. Aaliyah or Kingston should be able to answer this.
72 over 360 times 100.
Very good. That's a very good answer. So what we're gonna do here is we first have to find the fraction for rainy. So what's the fraction for rainy? It's gonna be what?
72 over
72 over what?
360.
Over 360. That's the fraction for rainy. So 72 over 360. That is the fraction representing rainy days. Now, we want percentage though. So in order for us to get a percentage, we have to multiply by what? Multiply
100?
by 100. Very good. So that's going to be 100 because we want the percentage, right? 100 over 1. Now the next question is, can we cancel on anything? Is there anything we can cancel?
Yes, sir.
Yes,
Yes,
we
sir.
can. So we cancel this 0 with that 0. And so we have what? 72 multiplied by 10 and 36 multiplied by 1.
1.
So it's going to be 720 all over what?
1.
No? 36 times 1.
Oh, 360.
36. Okay, good. And so let's divide 36. I'm sorry, let's divide 720 by 36. How many times does 36 go into 72?
2 times.
36 times 2 is 72. Very good. So 36 times 2 is 72. And we subtract 72 minus 72 is
0.
0. We bring down the
0.
0. So how many times does 36 go into 0?
0.
0 times. So it's going to be 0. And so 0 minus 0 is going to be
0.
0. And so 720 divided by 36 is going to be
20.
20. So that means that what percentage of the days it was rainy? 20% of the days. 20% of the days was raining. Okay. Okay, so how do we do that? Let me recap that. The first thing that we do is we find the fraction of rainy days, and that's going to be 72 out of 360, right? But we want it as a percentage. So because we want it as a percentage, we're going to multiply it by 100. And so we say this cancel with that. And so we say 72 multiplied by 10. And 72 multiplied by 10 is going to be 720. And 36 multiplied by 1 is going to be 36. Then we divide. We divide 720 by 36 and we get 20. And so that means that our answer is 20%. So the percentage of days it was rainy is going to be 20%. All right. So let me ask Amarani. Amarani, can you explain how we got 20%?
You first have to find the percentage of the rainy day. Rainy. It is 72 degrees. So you put 72 over 360, which is the degrees of a circle, times 100 over 1. You cross out 1 0 in 360 and 1 0 in 100. And you multiply, which gives you 720 over 36. You then divide 36 into 720, which gives us 20%.
Thank you. Myla, can you explain how we got 20%? Where's Can you explain how we got 20%?
Yes, sir.
You sound very low. You sound very low.
I'm not sure why.
Like I could barely hear you. Are you using like a earphones or headphones or something?
Yes, sir, but these are the ones that I use almost every class.
You're very low. I mean like extremely low.
Can you give me a second, please, so I could try and fix it?
Yes, we can. While she does that, say again, explain how we got 20%.
Yes, sir. So we're gonna put 72 over 360 because 72 is the degrees, the degrees for rainy days. We're putting it over 360 because the circle should come up to 360 degrees.
Yeah.
The angles in the circle. Then we're gonna multiply that by 100 because we're trying to find the percentage. So it'll be 72 over 360 times 100 over 1. We're going to cross out the zeros.
Yes.
And we're going to multiply 72 by 100 and 36 by 1, which gives us 720 over 36. When we divide that, it gives us 20%.
All right, good. Thank you. All right, good. And Samantha, I need you to explain it.
For what percentage of days was it raining? So we use 72 over 360 times 100 over 1. We use 360 because the circles add up to 360 and 100 because we're looking for the percentage. Then you cancel out the 0 and 100 and the 0 and 360. And now you multiply 72 times 10, which gives you 720. 36 times 1 would give you 36, and you divide 720 over 36, which gives you 20%.
Thank you. Good. All right, good. So let's do another question. All right, do y'all understand this? Before I move on to the next question, let me know. Do y'all understand how we got it?
Yes, sir.
Yes, sir.
Okay, only 5 persons. How about the others? Do y'all understand?
Yes, sir.
I understand.
Okay, so let's do another question. So that means that 20% for the month of September, it rained 20% of the times, right? So this is another good question. September has, how many days are there in the month of September? Anyone know? Offhand?
I think 30 or 31.
I think 30.
30 or 31?
31.
31?
30. September, right?
September.
31.
31?
30.
Okay, September has 30 days. All right. How many days? How many days of these were sunny? All right, September has 30 days. How many days of these were sunny? Anyone have any idea on how to do that?
Yeah, so can I try, please?
Yeah, go ahead, try.
We're gonna multiply 168 over. Can you help me, please, Mr. Petit?
No, you say you say you know how to do it, so I give you
Yeah, sir.
anyone else?
I guess.
168 over 360 times 30.
Say it again.
168 over 360 times 30.
Okay, that's very good. Good, excellent. So she's right. So the first thing that we need to do is we need to find the fraction of what? Sunny days. What's the fraction for sunny days?
168 over 300.
Say it again. 168.
168 over 360.
168 all over what?
360.
360. Why 360?
Because
That is the degree of a circle.
Very good. All right, and then we say okay, and we have to multiply by what? Multiply by
You have to multiply by 30.
by 30. Why 30?
30 days.
30 days. Very good. So 30 days.
Excuse me, Miss Petit, can you hear me now?
Yes, I can hear you now.
Thank you. Yes, sir.
That's a little better. Okay, so 168 over 360 multiplied by 30 over 1. Can we cancel out anything?
The zero.
So we can
Yes.
cancel out
From
the zero.
360.
0 from 30 and 0 from 360.
Very good. So we cancel out this 0 along with this 0, right? Good. And then so we're gonna have 168 all over what? 360.
36.
I mean 36. 36 multiplied by what? 3.
3 over 1.
3 over
30
1.
over 36.
3 over 1.
51.
Good. That's gonna be equal to, what is 168 times 3? Let's multiply that.
504.
168
I
multiplied by
got that.
168 multiplied by 3. 3 times 8 is
24.
24. Put the 4 down, put the 2 up. 3 times 6 is
18.
18. And 18 plus 2 is
20.
20. Put the 0 down, put the 2 up. 3 times 1 is
3.
3.
plus 2.
5.
5.
Very good. 5. So it's gonna be 500 and what? 504. 504 all over what? 36.
36.
And then now we have to divide, right? We have to divide 36 into 504. How many times does 36 go into 504?
14.
Say it again.
14.
14. So 36 goes into 50
Once.
once. Yeah. So 36 times 1 is 36. We subtract That's gonna be, this is gonna be 4. This is gonna be 1. 10 minus 6 is what? 4.
Four.
4 minus 3 is 1. We bring down the 4. So it's gonna be 36 into 144. That's gonna be what? 4
4.
times. Yeah, so 36 times 4 is gonna be 144.
44.
So we subtract, right? 144 minus 144 is going to be
0.
0, 0, 0. And so the answer is going to be what? The
14.
answer is
14 days were sunny.
14. Good. So there were 14 days that were sunny out of the 30 days. So quick recap, what did we do? The first thing we did was we find the fraction for sunny days, and it was the fraction for sunny days. The fraction for sunny days is going to be 168 all over 360. Then we must multiply by 30 over 1. Why 30? Because there are 30 days, right? And then we do the cancel. So we cancel this 0 with that 0. Then we say, okay, well, 168 over 36. So we also have here 168 over 36 multiplied by 3 over 1. Multiplied by 3 over 1. And so we multiply 168 by 3. And we also multiply 36 by 1. 168 multiplied by 3 is what? What did y'all get for that? 168 multiplied by 3. What y'all get for that?
504.
504. Then we divide that by 36. So 504 divided by 36 is going to be what?
14.
14. Very good. All right, good. All right. Do we understand how we got 14? Do you understand how we got 14?
Yes, sir.
So,
Yes, sir.
All right. Anyone else understand how we got 14?
Yes, sir.
so
Okay.
Yes, sir.
Okay. Okay, good. Where's Aaron? Aaron, are you there? Aaron, are you there? Where's Aaron? Where's Aaron? I haven't been hearing from Aaron since Monday. Malik Rule, where's Malik?
Yes, sir. I'm here.
All right. Do you understand how we got 14?
Yes, sir.
Okay, explain how we got 14.
We divided 36 by 504.
Divide 36 by 504. No, start from 168 over 360. Start from that.
All right, so since the sunny days, for sunny was 168. I mean, we put that over 360 times the number that was mentioned inside of the question over 1. Since we could cancel out the 2 zeros, we canceled the 0 of 3 and 360. Which then turned it into 168 over 36 times 3 over 1.
Good.
We multiply 168 by 3, which gave us 504.
Yeah.
And 36 by 1.
Which gives us what?
Which gives us
36.
36. Now we divide that by 504.
Okay, good. And so
Which-
when we divide it, what do we get?
Which then gives us the quotient of 14.
Very good. Michael, explain how we got 14.
So first, the question says September has 30 days. How many days of this was sunny? So the degrees for sunny is 168. So we have to put that as a fraction, which will be 168 over 360. Then you times that by 30 over 1. Then you cancel out the 0 and 360 and the 0 and 30. And then you write it again, which will be 168 over 36 times 3 over 1. Then you times 168 times 3, which is 404. And you times 36 times 1, which is 36. And then you divide 504 into 36, which is 14.
Thank you. And Myla, explain how we got 14. Where's Myla? Yeah, enough for Myla. Where is Aliana? Are you there? And Amaronik, are you there?
Yes, sir.
Okay, good. Explain how we got 14.
We have to find the fraction for sunny days. So they give us the degree is 168. So we put that over 360, which is the degrees of the circle, times 30, which is how much days are in September, over 1. We cross out the 0 from 30 and the 0 from 360, which leaves us with 168 over 36 times 3 over 1. We then multiply 168 times 3, which gives us 504 over 36. We divide 504 into 36, which gives us 14.
Thank you. All right, so do we understand how we got this?
Yes, sir.
Yes,
All
sir.
right. All right, good. Anyone else?
Yes, sir.
Do you understand?
Yes, sir.
Yes.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
All right, good. All right, let's move on to the next question. All right. It's gonna be the last one on this question. It's gonna be D. Write the fraction representing cloudy in lowest terms. So write the fraction representing cloudy, let's say cloudy days in lowest terms. All right, so okay, so what fraction represents cloudy days?
120 over
120, 120, right?
over 260.
120, all over what?
360.
All over what? 360. 360. So let me erase this. So 120 over 360. All right, so is that in lowest terms, or we could do something to it to make it better?
We can make it lower.
You could cancel out the zeros.
Cancel the zeros, yeah. So that's the first thing, which is basically dividing by 10. So we could cancel out this 0 along with that 0. So it's going to be equal to 12 over what?
36.
36, yeah. And we still could go lower. How could we go lower with this one? What we have to
We
do?
could divide it.
Divide both top and bottom by what number?
12.
Divide by 12? Yeah, 12 is the perfect one. So divide by 12. So we divide the top by 12. So it's going to be 12 divided by 12. We divide the bottom by 12.
1 over 3.
So 12 divided by 12 is
1 over 3.
1.
1.
Very good. And 36 divided by 12 is what?
3.
3. So the answer is going to be 1 over 3. Samantha, explain how we got 1 over 3.
All right, we're looking for the fraction for cloudy days in lowest term. 120 over 360. We cancel out the zeros in 120 and 360, which gave us 12 over 36. We divide it into 12. 12 divided by 12 is 1, and 36 divided by 12 is 3.
Very good. And no. Yes, Jeremy?
Can you explain A? I wasn't here for A.
No, I can't explain A. What you need to do is come to class early. You always do this all the time. You always come to class late. I don't want me to explain it. That don't make no sense. Come to class early, on time next time. All right. Okay, so do we understand how to do these questions?
Yes, sir.
Yeah, so
All right.
Yeah.
Good. So let's do one more example before we go to the great exercise. I think we got one more example in us. So what I'm going to do, I'm going to take a screenshot of this and put it inside the chat for those persons who need the example. All right, let's go. Let's do another example. So example number 2. And Jeremy, make sure you're paying attention for this one because you missed the first one.
Yes, sir.
So we're gonna take our compass and draw our circular shape. So let's say that we have this. Again, let me change the color. Let's change it to, yeah, let's use green. So we have this one, and let's say we have, let me make it smaller. So we're not gonna have that. I mean, I guess so. We could still have that large space here. But use a ruler to draw these line segments that we have here.
Mr. Petit,
Uh-huh.
could you put example 1 in the chart?
Let me put it inside the chart. Okay, it's there. Okay, so we have this one like that, and this goes like this. Okay, so let's say that this one is so this one is windy. Let's say that this one is hot. Let's say that this one is cold. All right, so for the number of cold days, we're gonna say that there are 36 cold days. Well, not 36, I'm sorry, 36 degrees. For hot days, let's just say that there are, so that there's 134. Let's say it's 134 degrees for the amount that it takes up in the circle, 134 degrees. And let's begin with the question. So we're gonna still keep it for September, but the pie chart shows the weather for the month of September. We're gonna calculate the angle representing not cloudy days, but windy days. Windy days. And it says for what percentage of the days was it, I think I say rainy, but that's percentage of days was it cold? And then September 30th, how many days were hot days? Hot days. I write a fraction representing windy days in lowest terms. So let's quickly do this. I need a volunteer for A, calculate the size of the angle representing windy days. How are we gonna do that? For windy days, what are we gonna do?
You're gonna add 134
plus 36.
We have to add 134 degrees.
36.
Plus what?
Plus 36.
Plus 36, very good, plus 36.
I just.
And what's that gonna be equal to? What is that gonna be equal to?
$170.
Very good, 170. And then what are we gonna do with our answer?
Subtracted from 360.
Very good, subtracted from
360.
Very good. So subtract. So we're gonna say 360 minus so 360 minus what? 170.
70.
That's gonna be equal to what?
190.
190. Very good. 190. So the first thing we do for this one is we have to add. So we're gonna add the degrees that we get, 36 and 134. And then we're gonna subtract it from 360. Why are we subtracting it from 360? Does anyone know? Why are we
That's the
subtracting
size
from
of the
360?
circle, which is 360.
So we subtract it from 360 because angles around a point add up to 360 degrees. Indeed, angles inside a circle add up to 360 degrees. So the angles that are inside the circle gonna add up to 360 degrees. So we're only missing this one. So in order to figure out what this one is, for windy, we're gonna subtract 360 and 170. That's the sum from hot and cold, and then we get 190. Now this is interesting. It says, but the percentage of the days that were cold. Percentage of the days that were cold. How are we gonna get that one?
36
36.
over 360.
36
Over 360. So we write the fraction of cold days.
Multiply by 100 over 1.
Multiplied by
100 over 1.
100 over 1. Why are we doing by 100 over 1?
Look for the percentage of
Very
the
good, because we're trying to find the percentage. Good. What are we gonna do at this point?
Cancel a 0.
Cancel
Cancel the
zero.
zeros. Good. So this 0 is gonna be with that 0. So that's gonna be equal to
And 36 times 10.
36 times 10. What is 36 times 10?
360.
360.
Over 36.
360 all over what?
36.
36. 36. And 360 over 36 is gonna be what? That should be
10.
easy. 360 over 36 is 10. So what percent is it? Is what?
10%.
10%.
10%.
Very good. 10%. 10%. So what do? We do 360, and we put that on top. We put on top we put 36. On the bottom we put 360. So we say 336 all over 360 multiplied by 100 over 1. Then we cancel the zeros, right? And then we say 36 multiplied by 10. 36 multiplied by 10 is 360. Then we say 36 multiplied by 1. Let me show the arrow for that. 36 multiplied by 1. 36 multiplied by 1 is going to be 36. And so we say 360 divided by 36, which is going to be equal to 10%. All right. Now, September has 30 days. How many days of these were hot days? So we're going to do that one. We're going to do hot days.
You do it of 34 over 134 over 360 times
134 over 360
times 30 over 1
multiplied by 30 over 1. Very good.
Cancel the zeros.
Good. We cancel the zeros. This 0 cancel with that 0. So we are left with what?
134 times 3 over 1
over
and
over
30.
36 over 36. I mean over 36 over 36
36.
multiplied by what?
3
3 over
3 over 1.
Good. What is 134 times 3? I got 402.
I got
402 divided by what? divided by 36.
36.
Good. And so what do we get when you divide them? 11.
11.16.
11.16. So I'm just gonna keep it as 11.2. All right, so I just round it to the nearest 1 decimal place. So we get 11.2. Okay, and then the last one, right? The fraction in lowest terms representing windy days. What is that? Windy days is
190.
190. 190, yeah. Windy days is 190, so it's gonna be 190 over what?
360.
360. So we say 190 all over 360. Multiplied by, no, we don't multiply by nothing. We just have to simplify it, right? Ooh, man, ouch. I'm sorry, I have to do that again. I'm sorry. Let me do this again. Okay, so I misimpressed the wrong thing. So what did we do for this again? We did 134 hot days. What did we do? We did 134 over what?
Over 360.
Over 360. We multiplied it by 30
over 1.
days. Yeah, 30 over 1. Multiply by 30 over 1. Then we cancel the zeros. So this 0 cancel with that 0. So we are left with 134 multiplied by 3 and 36 multiplied by 1. So 134 multiplied by 3 is going to be, oh, let me just put it there first. Let me, before I even do that. Let me don't multiply them out yet. So let's say we have 134 over what? Over 36. That's going to be multiplied by 3 over what? 3 over 1. Yeah, good. And so now what we're going to do, we're going to multiply what? 134 by
134 by 3.
Times 3.
by 3. Very good. And 36 multiplied by 1.
1.
What is 134 multiplied by 3?
402.
402. So we say 402 over 36. Then we divide and we get 11.2. 11.2. All right, write the fraction representing windy days in lowest terms. Write the fraction representing windy days in lowest terms. So windy days is 190. It's going to be 190 all over what?
All over 360.
All over 360. Let me erase. So 190 all over 360. We have to cancel out the zeros. So this 0 cancel with that 0. That's going to be equal to 19 over what?
36.
19 over 36. Now, is this in lowest terms or we could go lower?
That's in lowest terms.
It's in lowest terms, you agree?
We could go lower.
We could go lower? Or it's in lowest terms?
We could go lower. Yeah.
Hello, class. Is it in lowest terms or we could go lower?
It's in the lowest term.
That's in lowest term.
It's in lowest term.
It's in lowest terms. Why do you say it's in lowest term?
Because
19 is
19
the
is
prime
the
number.
equal number.
Because 19 is a prime number. Okay, so we can't go lower than that. All right. So the answer is 19 over 36. Good. All right, so do we understand how to get the answers for this? Again,
Yes,
do we
sir.
understand how we get the answers to that? Okay, I'm not talking only to 2 persons. I'm talking to the whole class. Do we understand how to
Yes,
get?
sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right. Still, some persons are not answering me, like Michael and Joseph. I asked if you understand. That's my question.
Yes, sir.
Yes, sir.
All right. Someone has asked me a question.
Yes, sir. You could explain B over, please.
B. Read B for me.
For what percentage of the days was it cold?
Okay, what part don't you understand?
So we have to do 100 over 1.
Yeah, 100 over 1. Always, because you're trying to change it into percentage. All right, so, you know, because you're trying to change the percentage, you take the fraction, which is 134, right, over 360, and then you multiply it by, you say B, right? So you take 36
Yes,
over
sir.
360, then you multiply it by 100 over 1. Always 100 over 1 because you're trying to change it into percentage. And then you divide the thing, and you get 10%. All right. Okay, okie dokie. I need Myla. Myla, are you there? Where's Myla?
Yep, yes, sir. I'm yes,
Okay.
sir.
Okay, good. Explain. Explain. I need you to explain this question, please, starting from A all the way to the last one.
Yes, sir. So for A, it says calculate the size of the angle representing when it is. In order to get the answer for this, we have to subtract the angles what we already have, which should be 134 degrees for hot and 36 degrees for cold.
Mhm.
First, we have to add though, and that would give us 170. Then we separate 360 since that's peripheral of the circle by 170, which would have been the answer for the addition problem, leaving us with 190.
Okay, good. Moving right along.
For B, it says for what percentage of the days was it cold? Where we have to put 36 over 360. Since we're dealing with the temperature that is cold and the angle for cold is 36, we put it over 360 and we times it by 100 over 1. That leaves us with 360 over 36, which equals 10%. The C, September, the question reads, September has 30 days. How many days of these were hot days? We take the degrees from the hot days, which would be 134, and put it over 360, then times it by 30 over 1. And we take one of the zeros off of 360 and the other one off of 30, leaving us with 134 over 36 times 3 over 1. And our answer would be 402 over 36. You divide those together and get 11.2. And for the final question D, it says write the fractions representing the windy days in the lowest terms, which would be 190 over 360, which equals 19 over 36.
Very good. 19 over 36. Okay, thank you. Juan, explain how we got it. Starting from A to D.
Yes, sir. First, the question is asking us to calculate the size of the angle representing windy days. First we need to find out how much is what's the percentage for the degrees for hot and cold. So we know that hot is 134 and cold is 36, and we add both of those and we got 170. And we have to subtract by 360 because we learned that angles in a circle add up to 360. So we say 360 subtracted by 170, which is 190. And for B, the question is asking us to find for what percentage of the days was it cold. So what percentage of the days was it cold? So we have to find out what percentage is but it's cold
Mm-hmm.
in the diagram. So we say 36 over 360 times 100 over 1, because we have to multiply by 100 over 1 because we have to find out the percentage in the question. So we say 36 times 10. I mean, we say 36 over 360 times 100 over 1. And we know that we could cancel out the 2 zeros. And then we say 36 over 36 times 10 over 1. So now we say 36 times 10 is 360. And we say 36 times 1 is 36. So we get 360 over 36, which is 10%. And for C, the question is asking us to find September has 30 days. How many days of these were hot days? So we say 134 over 360 times 30. The reason why we have to multiply by 30 is because the question says September has 30 days. So we have to find out how many days in September were hot.
Yes.
So we say 134 over 360 times 30 over 1. We could cancel the 2 zeros. So now we say 134 over 36 times 30, times 3 over 1. So we say 134 times 3, which is 402. And we say 36 times 1, which is 36. And we get 11.1666. So we round to the nearest decimal point. So our new answer is 11.2.
We round to one decimal place.
To one decimal place. And our answer is 11.2. And for D, the question is asking us to write the fraction representing many days in lowest terms. Write the fraction representing many days in lowest terms. So we have to find out what is many days. How much is many days? So we know that it's 190 over 360. But that can be reduced. So we cancel the 2 zeros, and our new answer is 19 over 36. And 19 over 36 is the lowest we could go, the terms.
Very good. All right, now it's time for us to do the grade exercise. What I'm going to do is I'm going to put the example number 2 inside the chat. Before we go, how many persons understand this before we go? You understand how we
I
gotta
do. I do. I do. I understand.
Okay, good.
I understand.
I do.
All right, good. So let's go ahead and do the question. Let's do a grade exercise. We're gonna have 3 of them. So maybe I don't know, maybe two would be fine because what's 713. Okay, so this is number 1. Let me do another one. So we have snowy, humid, and misty. Let's do another one. So say
Mr. Pate,
your
screen moved from
oh, my screen didn't share. Okay, thank you. Okay, you probably should be able to see it now. Can you see it now? Okay, good. So that's number 1. Quickly do number 1. I think I'm only gonna give. Let's do 2 and let's see how far that carries us. Nah, nope. Let's do 3. Let's do 3. All right, so for this one, we're gonna have overcast. Foggy. And let's say that the other one is stormy. For let's say it's
Can I use the bathroom, please?
yes, you can. And so first 144 and say that this is 66 degrees. And the question is the same. So you want to figure out, it's going to be for number 2. I want the size representing stormy days. I want the percentage of days that are overcast. I want the number of days that are foggy. 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 And I want the fraction representing stormy days in lowest terms. I'm just going to give you 2 for the sake of time. So let's just do 2. Okay, good. Zara Hannah, where's Zara Hannah? What number you on, Zara? Zara Hannah, where's Zara? Can't from Zara. Will on, what number you on? Wait, did she answer in the chat?
She answered in the
Oh,
chat.
Said 2A, okay. Will on, what number you on? Will on. Will on, what number you on?
Number 1B.
Number 1B, okay, good. And Will on, were you here last week?
I think so.
Or you, what did we do last week? Were you here for like the receipts when we was doing the receipts? Receipt and total bill? Or no?
I think I was there. I can't remember.
Okay. And Tyrone, what number you on?
1B.
Say it again.
1B.
1D. Okay, and Summer, what number you on?
Yes, sir. I'm
What
on
number?
I'm on number 1A.
Number 1A, okay. And Shekinah, are you on the exercise yet, or are you still working on the notes?
I'm on the exercise.
Okay. What number you on?
1A.
1A. And Shannon Roll, what number you on? Where's Shannon? Shannon Roll, what number you on? Okay, 1C. Okay. And Samantha Taylor, what number you on?
1D.
1D. Okay, good. Sabria, what number you on? I can't hear you, Sabria. Hello, Sabria.
I'm on 1D.
1D, okay. And Ronisha, what number you on? Ronisha. Here's Ronisha. Okay, 1C, okay, good. And Omari, what number you on? Omari, what number you on? One B, okay, good. And Olivia Albury, what number you on? Olivia.
1D.
1D,
Yes.
okay. Nivea, what number you on? Nivea, what number you on? Where's Nivea? Nivea Garden? Can't have from Nivea for some reason. Where's Nivea?
Yes, sir.
Yes, I was calling your name for a very long time. Why are you not answering to your name?
I just hearing you.
I'm saying, what number are you on?
Oh, I'm on number 2.
Number 2, okay. And Nevaeh Wallace, what number you on? Nevaeh Wallace. Nevaeh Wallace, where are you? Can't have from Nevaeh. Nevaeh Carey, what number you on?
I am on number 1D, sir.
1D,
Yeah, sir.
okay. And Nakari Roberts, what number you on?
1C.
1C. Do you understand what you're doing?
Yes, sir.
Did you send me the notes from yesterday?
No, sir.
Hello, good evening. Yes, ma'am. I'm calling Nevaeh Wallace inside the class and she's not responding.
Give me a minute, because she's in our room. Let me check on her.
All right then, thank you. Nakari Roberts, why are you not sending me the notes? Hello, Nakari.
Yes, sir.
Why don't I have your notes from yesterday?
Because I forget to send them.
No, you can't be forgetting to send the notes. When you send the notes for today, make sure you send the notes from yesterday. You understand me?
Yes, sir.
And stop forgetting to send my notes. You do that all the time. So you need to stop that. That don't make no sense. Do you hear me, Nakari?
Yes, sir.
You have to be responsible, man. Where's Myla?
I'm right here.
What number you on?
I'm on 1C.
So what happened to the notes from yesterday?
I think I sent them.
No, the last thing I have from you, from your mommy, is from Thursday.
Yes, I'll double check. Yes, sir.
Actually, not even from Thursday, from Wednesday of last week. Michael, what number you on?
1C.
1C. Do you understand what you're doing?
Yes, sir.
Okay, good. And Mark, what number you on?
1D.
Okay. You understand what you're doing, Mark?
Yes, sir.
So are you writing down everything I have, or are you just writing down piece? I'm talking to you, Mark.
I'm writing down everything.
Okay. Where's Malik Rule? Malik Rule?
1C, sir.
Say it again.
1C, sir.
1C, good. Malia Rule, what number you on?
1C.
1C. Kingston, what number you on?
I'm on 2A.
2A. You understand what to do?
Yes, sir.
All right. All right. Good. And Kevin, what number you on?
Number 2A.
All right. Kevin, what number you say you on?
Number 2A, sir.
Number 2A. And Kiajane, what number you on? Kiajane? Right,
Yes, sir.
what number you on?
1C.
1C, okay. And Kema, what number you on?
1D.
1D. And KC Hamilton, what number you on?
I'm on number 2A, sir.
2A, okay, good. And Juan, what number you on?
Number 2B.
Okay, good. And Jeremy, what number you on?
1B, sir.
Good. All right. And Jalen, what number you on?
1D.
1D.
Invisibility. Major
Go.
dash from this.
Yes, we can. All right, Jalen, what number you on?
1D.
1D. And Gilbriana, what number you on, Gilbriana?
1D.
1D, okay, good. Evanice, what you working on? Where's Evanice?
I'm on the last YXL quiz.
Okay, good. And Jevin.
Yes, sir.
Which number you on?
I'm doing 1C.
1C, good. Egypt, what number you on?
2.
Say it again.
2.
Okay, and Doronic, what number you on?
2D.
2D. Again, make sure to take a picture of your work and send it to me via WhatsApp again. Make sure to take a picture of your work and send it to me via WhatsApp. Where's Dia? Dia, what number you on?
2A.
2A. Demetria, what number you on?
2Z.
2C. Do you understand what you're doing, Demetria?
I doing it from the example. I can
You-
understand.
You're doing it from the examples? Okay, good.
Yes, sir.
All right, good. Siren, what you working on? Siren? Where's Siren? Siren Yubol, are you there? I can't hear from Siren. Clement Knight, what
I'm
number you
here.
on? Yes, Siren, what number you? Are you right doing this or are you doing something else?
I'm doing it.
Okay, what number you on?
8.
Number
2A.
2A. Sky, where's Sky?
Yes, sir.
What number you on? I mean, not the number. I think you on IXL, right?
Yes, sir.
Okay, good. So, what's your smart score is?
I just started the multiplication one, so it's on 36.
Okay, you understand what you're doing?
Yes, sir.
Okay.
It's like one of them, one or two of them. No, just one so far. I don't understand.
Okay, what does it what does it
I
say?
was saving it for last. I was using my calculator, but it's getting different numbers, so I did not understand at all.
Oh, okay. And Joseph, what number you on?
Let's finish.
You finished?
Yeah.
Pardon?
Yes, sir.
Okay, good. Anyone else finish?
So
Yes, sir.
Okay. Take a picture of your work and send it to me via WhatsApp again. Once you finish, take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp once you're finished. China, what number you on?
1D.
1D.
Excuse me,
Joseph, Joseph, did you send in your work already?
Excuse me, Mr. Boutique.
One moment. Joseph, did you send in your work?
Oh, no, sir. Yes, sir.
Okay, make sure I send it. Go ahead, Amari.
Mr. Boutique. My mommy told me to ask you if I can leave because I also gonna go for 8 o'clock.
Did you send in your work yet?
No, sir. I'm on 2B.
Okay, send what you have and then you can go.
Okay, thank you.
All right, and Chai, what number you on, Chai?
Number 2.
Number 2. Brighter and Grass, what number you on? Bri, what number you on?
I'm on 2C.
Lucy. And Bree, what number you on?
2B, sir.
2B. Brianna Roll,
Yes, sir.
what are you working on?
I'm on 2C.
2C. Okay, good. And Rashawn Turngrass, what are you working on?
IXL quizzes.
Okay. All right, what is smart score is?
$81.
81. And Bethany, what number are you on? Bethany, what number you on?
I already sent my work.
I can't hear you. Say it again.
I already sent in my work.
You already sent in your work. So you're finished.
Yes, sir.
Okay, that's good. All right, and Brene,
2C.
2C. Brene, what school do you go to again?
Bishop McElden School.
Okay, yeah. Okay, I understand you having a mock coming up soon. What are the topics that are gonna be on that mock?
They didn't give us it yet, but basically what we did from grade 7, all the topics. I
So
think.
is it going to be like it's a mock BJC exam? Is that what this is that what they're saying?
Yes, yes, sir.
Okay, all right. And what's her name? Ashton Webb. What number are you on? Where's Ashton?
Excuse me.
Go ahead, Demetria.
I do my work in the bathroom. My phone.
No, you have to do your working so I could see you.
Do it.
You have to do the working so I could see it.
Oh my God.
But I already do in the back of my book.
So you have to rewrite it, Demetria. Ashna on 2B. Angel, what number you on? Where's Angel? Angel, what number you on? All right. Are we ready to go over the answers? Are y'all finished?
Yes, sir.
Okay, good.
Yes, sir.
No,
Okay.
sir.
No, Javin, you're not done. Anyone else finished and ready to go over the answers?
I am.
Okay.
I'm finished.
Okay, good. Let's go over the answers and let's see how we did. All right, so the first question, Samantha, what do you have for A? It says calculate the size of the angle representing snowy days. So what did you get for that one?
Well, I had 108 plus 82 was 190. 360 subtract by 190 is 170.
So you got 360 minus 190, and it's going to give you what?
170.
170. Did anyone else get 170 for this particular one?
I did.
I did.
I did.
All right.
I
Anyone
did.
else? Anyone else? Only 5 persons. Anyone else
did.
got 170?
I did.
Okay, good. Excellent. And then it's the next one says, what percentage of the days was it misty? Anyone? Any volunteers for that one?
I'll do it.
Jevin, let someone else go. You still have work to complete. Anyone else?
30%.
How did you get your answer? Anyone else?
108 over 360 times
Okay.
100 over 1.
So we do 108 divided by what?
360
360
times 100 over 1.
times 100 over 1. And what's your answer when you get that?
30.
30. Very good. So we're gonna do, that's very good. So we're gonna do 30%. Very good. So that's, let me put it there. So we have 108 divided by, what's the division sign? 108 divided by 360, because that's the amount of, what's the sum of the angles? So it's going, then we're gonna multiply it by what? 100 over 1. And that gives us what? 30%. 30%. Anyone else got 30% for number, for B,
did.
for 1B? Anyone else got 30% for 1B?
I did.
Very good. Anyone else?
I did.
I did.
I did.
I did.
Okay,
I did.
good. So 30% is the correct answer. Renee, did you get it?
I got 130, but I didn't do it that way.
You got 30?
Yes, sir, but I didn't do it that way.
How did you do it?
I did 108. I did 108 over 360 times 100. Then I
Yeah.
crossed out the zeros and 360 and 100, and then
Yeah.
I did 108 divided by 360 because 36 would go into 108 3 times.
Uh-huh.
And then I did 3 times 10, and 3 times 10 is 30.
Okay, that's exactly right. And that's what we have here too. I just wrote it across, but it's the same thing. 108 divided by 360 multiplied by 100. So good. Okay, September has 30 days. How many days were human days? How many days were human days?
82.
What you got? Nakari, I mean, not Nakari, what's her name? Nevaeh, what you got?
I didn't got an answer, but I didn't finish subtracting it. My last question, not question. The last thing on my get was 166 over 1, but I didn't finish dividing.
Okay, anyone finish part C? Anyone finished part C? Could help us with that? What you got?
For my answer,
Yeah,
I got 6.8.
6.8. Okay, how did you get that?
I said 82 over 360 times 30 over 1.
Wait, let me I put that in now. So you said, let me stop this down. Okay, go ahead now. What you saying?
I said 82
Mm-hmm.
over 360 times 30 over 1.
Mm-hmm.
And I cancel out the 2 zeros.
You say 82 over 360 multiplied by
30 over 1.
30. Very good. Why 30?
Because the question said September has 30 days. So
Okay.
that's why I'm gonna multiply by 30 over 1.
Good. We do the canceling.
That's all.
What do we get?
And now it's gonna be 82 over 36 times 3 over 1.
So it's gonna be what? 246 over what?
36.
Good. And 246 over 36 is gonna be what?
It's gonna be 6.83333 repeating.
Very good. So it's 6.8. Good. Anyone got 6.8 for this one? 6.8.
I did.
I did.
Sir. I did.
I did.
Anyone else?
I did.
Yes. Yes, Clement.
I put 6.8333 repeating.
Okay, that's fine. I just wanted to one decimal place. Okay, where's Aaron? Aaron, are you there? Can Aaron hear me? Where's Aaron? I wonder if he could hear me. Is Aaron there? Ajani, are you there? Where's Ajani? Ajani, are you there? Can't have him, Ajani. No, Aaron. What's up with the A's today? Okay, write the fraction representing snowy days in lowest terms. So how are we gonna get that? Snowy days in lowest terms.
170 over 36.
So the end.
170 over 36. Cancel a 0.
170 over 36, not 36. Over what?
I mean 360.
Over 360, very good. And then what we have to do now, we have to do what?
Cancel the 0.
Cancel out the zeros, so this 0 cancel out with that 0, so we left with what?
17 over 36.
17 over 36. Did anyone get 17 over 36?
Yes, sir.
Okay, only
Yes,
2
sir.
persons. Anyone else?
I
17 over
did.
36.
I did.
Okay, very good. So
Yes,
it's in its simplest form, and we know it's in the simplest form because we can't go lower, right?
17 is a prime number.
17 is prime, yeah. Okay, good. Now, next up. the chart shows the weather for the month of September. Calculate the angle representing stormy days. How are we gonna get that one? Stormy days, the angle representing stormy days.
We're going
Which
to
all of
add
that?
66 plus 144 first.
Very good. So we add 66 and 144. And then after that we do what?
We're going to subtract it by 360. So it's going to be 360 minus 210.
210.
So
How you got 210?
we got it from 66 plus 144.
Very good. And 360 minus 210 is what?
It's going to be 150. And the reason we put 360 because the angles in the circle add up to 360.
Yeah, very good. So for the rest of you who are still working on, I'm sorry, for the rest of you who are finished, take a picture of your work and send it to me via WhatsApp. Again, for those of you who are finished, take a picture of it and send it to me via WhatsApp. Now, we know that, so the angle for stormy days is 150. What percentage of days is it overcast? What percentage of days is it overcast?
I got 40%.
Okay, can someone explain how we got 40? Besides Aaron, I mean
144.
How we
over
got it?
144 over 360 times 100 over 1.
Very good. 144. 144 over what?
360.
Over 360. Multiplied by what?
100 over 1.
Multiplied by 100 over 1. Good. And then we're gonna cancel, right?
Yeah.
So we cancel this 0 with that 0. And so we left with what? 144
Times 10.
all over what? 36.
37.
Multiplied by what?
10 over 1.
10 over 1.
10 over 1. And so what we're gonna do here, we're gonna multiply 144 by 10, which is what?
1,440.
1,440. All over 36.
36.
So 1,000, well, yeah, 1,440 all over 36 is gonna be what?
40.
You got 40?
So
Anyone else got 40?
Yes, sir.
I did.
I got 40.
Yeah, it is
I
40.
did.
I did.
40%.
I did.
Good. Still only a few persons are answering. What happened to the rest of y'all? Did you
I
get
did.
40%?
I did.
I did.
Okay, so 40% is the correct answer. Now the next one is September has 30 days. How many days of these were foggy days? So how are we gonna answer that one? Let me ask Amaranik, help me with this one. How we got the answer for C?
You do 66 over 360 times 30 over 1. You cross out the 0 from 30 and the 0 from 360,
So
which
we
leaves
say,
you with
one moment, so we say 66, because that's the amount of degrees for foggy, right? 66 over 360 multiplied by what?
multiplied by 30.
Divided by 30 over 1. Good. And what do we do in this case? We are going to what?
Cancel out the zeros.
Very good. We're going to cancel out the zeros. So what does that mean? Well, that means that this 0 cancel out with that 0. And we are left with what?
66 over 36.
Very good.
Times
66. over 36
times 3 over 1.
multiplied by
3 over 1.
3 over 1. Good. Now what do we do next?
You multiply 66 times 3.
Very good. 66 times 3. And what is 66 times 3? That's going to be what?
198.
198. All over 36 over 1 is
36.
36. And then we divide 198 by 36. And that gives us what?
That gives us 5.5.
Just what you got? 5.5?
Yes, sir.
Okay. Anyone else got 5.5?
I did.
I did.
I did. I did.
I did.
I did.
Very good.
I
5.5
did.
is the correct answer. Very good for those who got 5.5. And the last question, write the fraction representing stormy and lowest terms. Mila, what we have for this? Where's Mila? What do we have for this? Kiana from Mila. Go ahead, Brittany. Wanna try?
Sure. So you get the 150 from Stormy, and you put it over 360.
Very good. So 150 over 360.
And you cross out the zeros.
Very good. So you cross out the 0. So this 0 goes with that 0, and it's gonna be equal to what?
15 over 36.
15 over
36.
36. Okay, good. And 15 over 36. How are we gonna do that? We're going to divide both sides by what?
3.
Mila, I still can't hear you. I still can't hear you, Mila. Divide both top and bottom by 3. So 15 divided by 3. And 36.
Excuse me, Miss Pretty, can you hear me now?
Loud and clear. So 15 divided by 3 is what?
Yes, sir, thank you.
What is
5.
15 divided by 3 is 5. 5, good. And 36 divided by 3 is what?
12.
Is 12, good. So the answer is 5 over 12. Did anyone else got that? 5 over 12.
I got that.
I did.
I did.
I did.
I did.
Good.
I did.
Good, perfect. Okay, good. Take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. Was there anyone who got all right? Was there anyone who got all
did.
right?
I
I
did.
did.
Okay.
I did.
Anyone got one wrong?
I did.
Anyone got one wrong? One wrong. Okay, if you got all right, put I inside the chat. If you got all right, put I inside the chat. If you got one wrong, put Y. If you got one wrong, put Y. If you got two wrong, put N. Again, if you got two wrong, put N. Where's Akiro? Where is Akiro? Where's Akiro? Akiro, where are you? Where's Akiro? Akiro, are you there? How about you, Ajani? Where's Ajani?
Yes, sir.
Okay, good. Ajani, did you send me your work from yesterday?
No, sir.
I need you to send your work from yesterday, Ajani, and also the work from the day. The same thing goes for Akiro. All right, so it's currently It's currently 8 o'clock, so that means that what we need to do is we need to go on to health science and general science. If you are not doing health science or general science, you are free to leave. Again, if you're not doing health science or general science, you're free to leave. But
Good night, Mr. Batiste.
good night. But the rest of us who are doing health science and general science, we have to stay back. Okay, the last thing we did in health science was what? We are looking at what?
Movable and immovable joint.
Okay, we didn't look at immovable joints. We just looked at movable joints. What type of movable joints we were talking about last week? What type?
Your shoulder, your pivot.
The ones that are on the shoulder, the ones that are in the elbows, the ones that are in the hip joint, right? Okay, what do we call the name of the joint that is able to go 360? That has a 360-degree rotation. What do we call it?
Socket joint.
Ball and socket, very good. Where can we find the ball and socket joint?
In the hip.
In the hip joints. Where else?
Shoulders.
In the shoulder, very good. All right, then we talk about also the hinge joint, right? Okay, where could we find the hinge joint? Where could we find the hinge?
knuckles.
In the knuckles. Where else?
Knees.
In the knees. Where else? And
I think elbows.
Elbows, right? Knuckles, knees, elbows. And what type of joint is found in, let's say, the neck?
Pivot joint.
The pivot joint found in the neck, okay? Okay, so good. So that's that. Today we're going to be looking at the injuries to the skeleton. Okay, so what do we call when we have some injuries to the skeleton? Now, different things could happen when you have injuries to the skeleton. You could have a fracture, you could have a sprain, right? You could even have arthritis. There are different things that could happen when you have injuries to the skeleton. So that's what we're going to be talking about for today, injuries to the skeleton. So let's look at that. That'll be our health science topic. So today is, let's set up properly. Today is Tuesday the 13th of February 2024. The subject is, of course, health science. And the subject is health science, and the topic is, anyone remember the topic? I just said it. I just said the topic.
Is it injuries to the skeleton?
No, Jevin. Injuries to the skeleton. That's what we're gonna be looking at. Injuries to the skeleton. Anyone ever broke a bone before? Anyone ever broke a bone? No one in here ever broke their bone. Wow.
So.
All right. Who's that person who said yes? Who's that person who said yes? They had a broken bone before. Anyone ever had to wear a cast? Anyone ever had to wear a cast?
No,
I
sir.
have.
Who said I have?
Tegan.
Tegan? Wow. Where? What? With
Yes, sir.
hand, leg.
My leg. I dislocated my patella.
Really? Wow. How?
I tripped over my bag.
Wow. And what? This isn't like sports related. It's just.
No, sir.
Okay. Wow. That's crazy. You ever had a cast too?
No, sir.
Okay. Wow, that's crazy. Okay, so I remember when I was in grade 3, I had a cast as well. But that was sports related because we were playing football. Well, not really, well, a version of football, let's put it like that. Because we didn't really have all the materials that we needed, but we just was playing in the schoolyard when I was in grade 3. Yeah, grade 3. And yeah, I literally broke my bone and I needed to we went to the orthopedic doctor. Anyone know what we mean by orthopedic doctor? Anyone know what we mean by that? Orthopedic doctor.
Person to check your bone.
That's like
Yeah.
when
Yeah, so
But I have a question.
uh-huh.
What bone did you break?
I don't even know which bone. I know it's my I know I had a long cast on my leg. So yeah, and I missed school. I missed weeks and weeks of school, and I had to walk around school with crutches and all them stuff. And so good thing I was young and it healed up and like nothing happened, but it was an injury. All right, so okay, so let's begin. So the first thing we're going to talk about is a fracture. So there are many common injuries that happen to the skeleton. Such as the first one we're going to be talking about is a fracture. A fracture. Now there are different types of fracture. You could have a closed fracture. You can have an open fracture. You can have multiple fractures. You could even have a spiral. So a fracture is basically a break in the bone. So when people say they break their bone, that's a fracture. So a break in the bone. So a break in the bone. That's what I mean by a fracture. Now there are many ways. There are many ways a fracture can be classified. According to how it occurs, or according to how the break occurs, the direction of the break, the direction of the break, the number of breaks, and so on. So anyone, do you know that your bone could break in such a way that the bone could actually show from the skin? Anyone know that? That your bone could break in such a way that the bone could.
Yes, sir.
Yeah. All
One
right. Good.
time my neighbor fell and his bone started poking through his skin.
Yeah, that's what we call that an open fracture. So an open fracture is when the bones start poking out, right? There's this famous guy, Paul George. Anyone know Paul George?
He was a basketball player.
Yeah, basketball player. Yes, Paul George from the Clippers. He still is a basketball player. He ended up healing, but he had a fall so bad that his whole it literally ripped through, and that was just it's hard to even look at, right? It's really hard.
Excuse me.
Uh-huh.
And you could fracture your bone in which a piece of the bone shatters.
Yes, that's the next one. So that's called that's another type of fracture where the bone actually shatters. Okay, so different types of fractures, we name them different type of things. So I just want to show you some versions of it so you can just get a sense of what we're talking about. And you can go online and always look at the other numerous ways that they have it. So there's one with, this one is called the grain stick. This one is called the transverse. The commuted one, that's the one where you talk about the shattering. The spiral one, what happened here? It looked like
It twists?
Yeah, it twists. It actually twists and broke. That's crazy. And then the compound one. Which one would you rather have? The green stick, the transverse, the commutative, the spiral, or the
None.
compound?
Green stick.
Green stick.
None.
None.
None, actually.
None actually.
None.
Yeah, I want
If you had to choose,
Green
The green
Yeah.
stick looks less painful.
Green stick.
Like it don't look like a little crack, but them
Yeah.
other set look
Like
very painful.
very painful,
I
right?
think I prefer the green stick fraction.
Yeah, the green. Yeah, just a little.
Because I heard in some cases, once you get a compound fracture, sometimes you may not be able to walk again.
Yeah, I mean, and that's when they start putting things inside of you. Okay, so that's a fracture. So let's look at the types. So the types we talked about. The green stick. Well, let me say it. Below we look at 3 types of fractures, but we know that there are more, right? So green stick, that's the little one, not so bad, little mild one, at least relative to the others, right? Clermont, are you there? Are you watching memes? Where's Clermont? Is Clermont there? So it's a fracture, a break in the bone that may be either partial, be either a full or a partial break. I think this is exactly what happened to me when I was younger. I probably had a green stick fracture, and I said it because this occurs mainly in children. And why do you think this type of fracture might occur in children? What do you think? What can we say about
Because children have stronger bones than adults.
children have stronger bones than adults? Are you sure?
They have
In some
softer bones than
instances,
adults.
like when they're younger, that they may be stronger than
What?
adult bones, so they can take
No,
more
definitely
impact.
not. Definitely not.
Children bones are more softer and weaker
Thank
and
you.
brittle.
Yes, children bones are softer, right? So it mainly happens in children. Why? Because their bones are not firmly developed, right? So mainly in children whose bones are not as hard okay. But they will normally heal in a week. Okay, normally heal in a week. Well, probably I didn't have a green stick because I didn't take a week. My own took weeks, and I lost a lot of time from school, a lot. All right, then the next one is compound fracture. So for compound fracture, it's actually supposed to say compound fracture. So let me correct that. It's supposed to say green stick fracture. Like, actually, that's the 2 words we want. And then this one is compound fracture. So this is when the bones are broken in multiple places. So the bone is broken in 2 places. This is sometimes called an open fracture. Remember, when do we call something an open fracture? When we call something an open fracture?
And you can see the bone.
It's when the bone sticks through the skin.
Yeah, when you can actually see the bone come out, right? And I've never seen that in real life. I don't know if I don't know if you've seen that in real life, but to see that in real life, that would be really, really intense. So this is sometimes called an open fracture when the bone penetrates the skin. Yes, Kiajane? Yes, Kiajane, you have a question?
I saw that in real life. At my school, a boy body slammed the next boy and he ended up broken his leg.
Wow.
Like that. It looked very disgusting.
Wow. Okay. Okay, so first question, what is a fracture? What is a fracture?
Broken.
A break in the bone. Very good. Question, whose bones are stronger, adults or children? Adults, good. What do we call a fracture in which the bone is exposed?
Compound fracture.
There's a specific type of fracture where you can see the bone itself. What do we call that type of fracture?
Common.
It starts with O.
Open fracture.
Open fracture. Very good. So an open fracture is when you can see the bone coming out. All right, good. Let's move on to the next question. Now we have co-minuted. Co-minuted fracture. Now, remember we talked about this one, or we saw the picture earlier? That's when it's actually shattered, right? So when the bone itself is shattered. So this occurs when the bone is shattered or broken in many places. So the shattering of the bone or the breaking of the bone into very small pieces is what we call the co-minuted fracture. So we have the fracture, breaking. Generally speaking, it's the breaking of the bone. A fracture don't have to be only one type. In fact, there are not only one type of fractures. We have different types of fractures. We only mentioned 3 inside this particular study: the grain stick, the compound, and the co-minuted fracture. One is where the bone is shattered into or broken into many pieces. I have many broken in many places. Oh yeah, broken in many places. Yeah, and the compound is when you have the bone being broken in 2 places, and when you have the skin being exposed, it's called an open fracture. And then the grain stick fracture is when you have a partial breaking of the bone, or even a full one, but it occurs mainly in children because their bones are not strong enough. So that's fractures. The next one is dislocation. Dislocation. Someone said that they had a... Say it again.
When you grow up, does your bone get stronger?
Yes, for sure. For sure. So dislocation. Someone mentioned that they had a dislocated patella. But this happens when the two bones at a joint are pulled apart. When two bones of the joint are pulled apart, and that is intense as well. Really imagine you have a joint and those two bones are pulled apart. That's probably very painful, like excruciatingly painful. But the good thing about this is that all you need to do is push it back into its position. So the bones may be pushed back into position. Dislocation. So when you have two bones of the joint being pulled apart, and we could just snap it back into position. Now, it still requires, in some cases, still requires, the healing process, but, So, Samantha, read for me the definition of dislocation.
Dislocation. This happens when the two bones at a joint are pulled apart. The bones may be pushed back into position.
Okay, thank you. And Myla, can you read the definition for fracture?
Yes, sir. A fracture is a break in the bone. There are many ways a fracture can be classified according to how the break occurs, the direction of the break, the number of the breaks, and so on. Below, we look at 3 types of fractures.
Thank you. All right, then the next one we're going to talk about is a sprain. It's a sprain. Now, anyone ever had a sprained wrist or any type of bone that was sprained before?
I had a sprained leg.
Sprained leg.
Yes, sir.
Sprained neck, okay.
I had a
Okay.
sprained leg.
Sprain. Okay, how did you get it? Was it from like sports or was it just like regular stuff?
Sports. We were
Sports.
playing a game and like there was this like gigantic rock in the middle of the way and I didn't see it and I just like tripped over it and I got sprained from it.
Okay. So you get sprained from tripping over stuff. Okay. So a sprain. It occurs when the ligament. Now ligament, does the ligament join bone to bone or bone to muscle? Ligaments. What did I join?
Bone to muscle.
Nope.
Bone to muscle.
Nope. Nope. Ligaments join what?
Bone to bone.
Bone to bone. Bone to bone. What joins bone to muscle?
Tendons.
Tendons. Very good. Tendons. Tendons. Let's try this again. Ligaments join what?
Bone to bone.
Bone
to bone. Bone to bone. And tendons join
Bone muscle.
bone to muscle. Good. Okay, so the sprain occurs when the ligament that holds the bones together. Sorry, ligament is spelled wrong. Is overly scratched or torn. This occurs most often in athletes. When the ligaments, when you overly scratch your ligaments, or even when you tear your ligaments, we call that a sprain. All right. Alrighty. And there are some more. The next one we're going to talk about is what we call a slip disc. It's the fourth one, a slip disc. So this occurs when the cartilage, and we said that the cartilage, talked about the cartilage before. The cartilage, is it rubbery or not rubbery? The cartilage.
Non-rubber.
It's rubbery.
It's rubbery, very good. And what's the purpose of the cartilage? To do what?
To stop bones from rubbing up against each other.
Very good. To stop bones from rubbing against each other. It prevents friction. So this occurs when the cartilage between the vertebra is, vertebra is displaced. This can cause a lot of discomfort or pain because the disc now pinches the nerve of the spinal cord. So last one is what we call the slip disc, and that's going to be the last one. Once you finish with your notes, take a picture of it and send it to me via WhatsApp. But the last one is the slip disc, and that happens on your spine, right? The slip disc. So as you can see, let me show you a diagram of it. So as you can see, this right here, that's what we mean by slip disc, and it causes a lot of discomfort for people, right? As you can see, this right here is not normal. All right, so it causes or affects your spinal area. Okay, that's the slip disc. Okay, so far we talk about 4 types of injuries to the skeletal muscle. Sorry, to the skeleton. Give me one type of injury to the skeleton that could happen. Anyone can answer.
Fracture.
A fracture. Anyone else?
Sprain.
Say it again.
Sprain.
A sprain. Okay, good. Anyone else? Dislocation. And the last one?
Slip disc.
Fracture.
Say it again.
Slip disc.
Slip disc. Very good. Good. Can someone read the definition for sprain? What do we mean by sprain?
Occurs when the ligament that holds the bones together is overly stretched or torn. This occurs most often in athletes.
Very good. And good. I need someone else to read dislocation. Dislocation. What is
I
dislocation?
can read it.
Go ahead. Go ahead, Brené.
Dislocation. This happens when the two bones at a joint are pulled apart.
Very
The
good.
bones may be pushed back into position.
Very good. Again, once you finish with your work, take a picture of it and send it to me via WhatsApp. Again, once you finish with your work, take a picture of it and send it to me via WhatsApp so that we can move on to general science. All right, I need your notes. I need all of it. So again, once you finish with your notes, take a picture of it and send it to me via WhatsApp. So those are some injuries to the skeleton. There's also something called rickets. We talk about that. That's when you have a deficiency where the body cannot absorb calcium or lack of vitamin D. And then arthritis. A lot of people talk about arthritis, you know. That's another one. So good. Again, once you finish your work, take a picture of it and send it to me via WhatsApp. All right, are we done with this slide?
Yes, sir.
Not yet.
Kevin is finished. Anyone else still working on it?
I am.
I am.
All right, Tyrone, Tegan. All right, just giving you some more time to work on that. Then we're gonna move on to general science. And we're gonna move on to general science.
I don't.
You're done? Good. All right, good. All right, so let's move on to the next question. Not the next question, to the next slide. I'm going to take a picture of this and send it to me. I'm going to take a picture of this and put it inside the chat for those persons who are still working. I'm going to put it inside the chat for you. All right, good. All right, so all right, so let me let's begin general science. So today is Monday, Tuesday.
Mr. Fatigue, I don't do general science.
Okay,
Good night, Mr. Newton.
if you don't do general science, you can leave. But for those of us who are doing general science, we stay. All right. Alrighty, good. Okay, today is Monday, Tuesday. Let's head up Tuesday. Tuesday. Where's Clermont? Clermont, are you there?
Yes, sir.
Okay, I was calling you earlier and you were not responding. Were you watching memes?
No, sir.
Okay, did you send in your work?
Yes, sir.
Okay. Okay, so our subject today is general science. And we said when we move from a liquid to a solid, what do we call that? It's going to be called what?
Freezing.
No, a liquid to a solid. Yeah, that's freezing. Very good. How about a solid to a liquid? What do we call that?
Melting.
Melting. Melting. Very good. Then how about when we go from a liquid to a gas?
Evaporation.
Evaporation. How about when we go from a gas to a liquid?
Condensation.
Condensation. Very good. How about when we go from a solid to a gas?
Sublimation.
And a gas to a solid?
Sublimation.
Sublimation. Very good. So there's a particular theory that we talk about that helps us to understand how the changing of state occurs. What's the name of that theory?
Kinetic theory.
The kinetic theory. Very good. The kinetic theory. And the kinetic theory tells us that when we add heat, the temperature of something increases and also the kinetic energy increases as well. All right. Okay, so today we're going to be looking at a very important topic. They love to bring this on your exam. We're going to be looking at physical and chemical what? Oh, you've already done this already in school. Changes, very good. Physical and chemical changes. So how do we determine whether a change is a physical change and whether change is a chemical change. How do we determine that? A physical change versus a chemical change. How do we determine those things? So let's begin. So a physical change, so we can start off with a definition of a physical change. Write this down for me, please. A physical change is one in which no new substance is formed. Right, so that's one of the hallmarks of a physical change. No new substance is formed. As a general rule, when we're dealing with physical changes, we don't have a new substance that is being formed, okay? It is sometimes called a temporary change. All changes of state, such as evaporation, melting, freezing, and condensation, are called physical changes. Now, when we say temporary, what does the word temporary mean? Can someone tell me what we mean by temporary? What does the word temporary mean? Is it
Only
not for
lasting
long?
for a short period of time.
Short term.
Only short term, only lasting for a short period of time. Good. Very good. So it means that it's not permanent, right? Because the opposite of temporary is what? What's the opposite of temporary? Permanent, right? Fixed, right? So when we look at a physical change is something that is reversible, right? It's reversible. So for example, if we take our water or our soda or our Kool-Aid and we put it inside the freezer, what's going to happen to that water? It's going to what? It's going to freeze, right? Okay,
Solid.
so it changes. So that's the physical change. It changes, right? So it was water in the liquid form, and then it became water in the solid form. But is it still water?
Yes.
Yes, it's still water. So no new substance is formed. It's still water. It was water as a liquid. You put it inside the fridge, it's water as a solid. It's still water. Now, my next question is, can it turn back into a liquid?
Yes, sir.
Yes.
Yes, sir.
How can we turn that solid ice into a liquid? What do we need to do?
Let it melt.
I melt in it.
We need to let it melt. So we need to expose it to what?
Heat.
Heat, right?
Heat.
So it could change back. So that's the thing about physical changes. Physical changes are reversible, right? Physical changes are reversible, which means that it could change back to the state that it was. So that's why it says it's temporary. It's a temporary change, right? So evaporation, all those changes of states, they are physical changes because they can change back into the state that it was in. Now, what happens if a new substance is formed? So let's talk about this. So if a new substance is formed, the change is called a what? If a new substance is formed, what do we call that change? If you have a new substance being formed,
Chemical change.
we call it a chemical change, right? Chemical change, very good. That's if a new substance is formed. Okay, we call that a chemical change. So what's the difference between a physical change and a chemical change? Anyone can answer? What's the difference between a physical change and a chemical change? Say it again. Hello. What's the difference between a physical change and a chemical change?
Physical change that you can like reverse it, and chemical changes like you have to replace it.
You can't reverse it. Okay. All right. Anyone else want to help him? What's the difference between a physical change and a chemical change? All right. I need y'all to answer me now. It's right on the screen. What's the difference between?
Is the substance is still the same substance as it was.
Okay, the substance is the same substance. Anyone else? I saw Bri was trying to answer. Go ahead, Bri.
A physical change is one in which no new substance is formed, and a chemical change is a new substance that is formed.
Very good. When a new substance is formed, we call that a chemical change. When no new substance is formed, we call that a physical change. Good, perfect. Okay, so for example, give me an example of a chemical change.
Wood burning.
Very good. For example, burning wood.
Metal rusting.
So when a new substance is formed, we call it a chemical change. So the burning of wood is one example. I'm only gonna give you one example, but there are some hallmarks of, there are certain features which characterize a chemical change, right? So what do we mean? So when a chemical change takes place, we may notice the formation of a precipitate, which is a solid, the next thing is effervescence taking place. What do we mean by effervescence? Anyone know? Effervescence taking place. What is effervescence? That's going to be what? Bubbles, what?
Isn't that when like the stuff to start forming suds or foam or something?
Yes, bubbles, right? So bubbles forming because we have a new substance being formed. So when a chemical change take place, we can notice certain things. Effervescence, we have a precipitate being formed, like a solid, like some powdery stuff, coming out of the reaction. We might have some misty fumes forming. You might have energy in the form of heat, light, energy, in the form of heat, light, sound, etc. may be given off. And then may even have a color change take place.
Like food dye.
Say it again.
Like food dye.
Well, food dye is not a chemical change. Because if you put food dye, let's say if you put that in water, right? The water changes color, but no new substance is formed. It's still a physical change, right?
Yes, sir.
Okay, good. Can you all still see the screen with the
Yes,
notes?
sir.
Yes, we can see
Yes.
it? Okay,
Yes,
good.
sir.
Yes, sir.
Good. All right, so I'm gonna say some stuff and you're gonna tell me if it's a physical change or if it's a chemical change. The first thing is cutting paper. Cutting paper, is that a physical change or a chemical change?
Physical.
Physical.
Physical change,
It's
very
a
good.
physical change.
Physical change, very good. Rusting of iron, is that a physical change or a chemical change?
Chemical.
Chemical change.
Chemical.
So the iron is going to react with oxygen to produce iron oxide. So that's definitely a chemical change. How about baking a cake? Is that a physical change or a chemical change?
Chemical.
Chemical?
Chemical.
Chemical? Okay, so why you say it's a chemical?
Because it cannot revert back to its original state.
Because they can't reverse back to the original state. So, and we have chemical reactions that occur between the ingredients in the formation of the cake, right? How about cooking egg? Cooking an egg. Is that a physical change or a chemical change?
Chemical.
Chemical.
Chemical change. Why? Because there's no reversing, right? How about boiling water? Boiling
Physical.
water.
Physical.
Physical, very good.
Physical.
How about this one? Crushing a can.
Physical.
Physical.
Question again?
Physical.
Yes. Crushing a can, it's physical, very good. Physical, good. So good, y'all are pretty good with that. So let's put those examples in writing. So here are 4 examples of physical changes. Grinding beans, that is chemical, right? I mean physical. Cutting paper, it's physical. Boiling water, and breaking glass. Those are examples of physical changes. And then here are 4 examples of chemical changes. Baking a cake, rusting iron, cooking an egg, and even the digestion of food.
Chemical.
Yeah. So these are all examples of chemical changes. All right, good. Once you finish with your work, take a picture of it and send it to me via WhatsApp again. Once you finish with your work, take a picture of it and send it to me via WhatsApp. And then you can leave.
Good night, Mr. Petit.
All right, good night. Good night. Good night.
Good night, Mr.
Good night. Good night. Again, for those of you who are finished,
Good
take a
night.
picture of your work and send them via WhatsApp. Good night. Again, for those of you who are finished, take a picture of your work and send it to me via WhatsApp. Again, for those of you who are finished, take a picture of your work and send it to me via WhatsApp.
Good night, Mr. Petit.
Good night.
Good night, Mr. Petit.
Good night.
Good night, Mr. Petit.
Good night.
Good night, Mr. Petit.
Good night. Again, once you finish your work, take a picture of it and send it to me via WhatsApp.
Good night.
Good night.
Good night, Mr. Petit. I'm gonna send it right now.
Mr. Batty, I just had. Good night.
All right, good night, Jeremy.